Okay, so our canvas is up and running as a substrate we can start to play around with. And so I can demonstrate this by just playing the raw transcript that's appearing and transcribing it here. So what we're in need of, however, is the animation framework for it. So text is just a little bit boring. It should be anything that appears here. It should be images, videos, shapes morphing around, graphs appearing. And so what we're in need of is a framework for connecting the output of an LLM, which is reading the transcript, and the Remotion animation primitives. So this is highly advanced. This is extremely difficult, and this is tons of code. But AI can generate tons of code, and AI can move from transcript to clear frameworks. And so I'm brainstorming here with Gemini 2.5 because Claude, for whatever reason, is non-responsive and has been so all day for me. And it's come up with this highly flexible dynamic scene approach. So this component would be the workhorse for rendering most LLM-generated scenes. So its primary prop would be a structured object representing the scene and its animations. So there's an animation primitive with the target ID, the ID of the scene element, I presume. The property, how this thing is going to be animated, is going to change its opacity, its X position, its Y position, its size, its rotation, color, text properties, from value, to value, its start time, and the duration, and the easing of this, okay? So these are the animation primitives, and to an extent, these will connect to, for example, how long a segment is, but it might be that these are hard-coded to an extent, okay? And then the other thing is just the scene element, and this as an ID. And it could be just plain text, as we have seen, or it can be other stuff like images. And the images, we're gonna generate a ton of Vibetube branding. Vibetube like icons that can appear in videos, or like image types with transparent backgrounds of like people, and just stuff that fills this very niche vibe. And there's just tons of stuff that is to be generated and connected to keywords. And the keywords is sort of, well, if there are objects in a scene being described that pertain to a finite vocabulary of what the LLM is saying, then it's going to use this image. And that image either exists already in the cache, it's already been created, or it's created when the user uses that keyword. I mean, there are millions of objects in the world that someone could mention, and these get cached. So it's not super expensive to do this. Okay, so that's the image. And these images could just as well be animated, okay? And they're also stored in the cache. And now they're going to be appearing here. These scene elements are going to be appearing somewhere in the canvas. They'll be covering maybe the whole thing. Whoop! All the way over here. Ship. and it's going to be fading in or moving, and it's all going to be this sort of Vibetube branding to it. It's like this retro feel, a way to do it, just like vinyl pixelated stuff in here and stuff like this. So the yeah, so or it could just be a shape or a graph or so on. There's more stuff in here to be created, and yeah, like different trees, or it's all this sort of whole world of animation. And the process of creating this may be the process of watching tons of talking head YouTube videos and seeing what people have done, and then just bringing it into the system, essentially. Okay, so it has this framework here. It seems to understand this well, pretty nice. So yeah, how to think about abstractions. LLM output schema is key. The most important abstraction is the structured data format that your LLM will output. This schema dictates what your Remotion components need to be able to understand and render. Start simple and expand. Maybe the first version only supports text with basic position and opacity animations. Yeah. Consider what's easy for an LLM to generate reliably. I think it should be able to figure out sort of scene objects. Yeah. Okay, well, this problem is hard, but if you solve it, you've created $1 billion company, basically. Yeah. So decouple LLM from Remotion internals. The LLM should not know about interpolate or use current frame. It should describe what to animate, and your Remotion components handle the flow. If you're using approach A, your dynamics scene.tx will have a lot of mapping logic. If using approach B, each primitive component encapsulates specific animation logic. This can be more modular and easier to maintain. Wait, I'm not sure I understand its idea with approach B. Specialized animation primitive components. Instead of one monolithic interpreter, you could have a library of smaller Remotion components, each responsible for a specific type of animation or element. Animated image takes image source and yeah. You'd still need a master template. Okay. Actually, and approach B a lot. Not yet decided. Yeah. The most, yeah, so we've gone through design your schema and components. Now, yeah, so this problem is extremely hard, but AI is damn good at it. It's phenomenally good at it. And it can just generate everything in the images, all the videos, and all the code to support this type of animation. And so while the world is focused on building the video editor for stuff like VO2 with this type of animation, we're doing something different here. We're building out the hard-coded library that is very cheap to do once it's built, and it has a massive production cost, and the production cost is just done by AI and very competent systems coders and thinkers. So so I'm just asking you, what's the incremental process of building this out? Because I'm thinking I just need a very clear example to start with that's going to plug into something here. And then I need to attract a system thinker that can like really appreciate this problem. So let's just see what it recommends. That's a great way to starting with a concrete sample animation definition for a transcript, using your proposed primitives and then building out the Remotion and AI sites incrementally as a solid plan. Let's break down the workload and the incremental process for both approach A and approach B. Yeah, so it's going to need sample animation definition. Say the transcript segment is LLM might generate something like this. Today we'll explore this opacity Y50 font size. Okay, underline. Fade in, sliding up. Exactly. It's going to do something like this. This is where the bulk of the initial technical development lies. Schema definition, defining the JSON structure. Special effects like typewriters. This needs to be robust and extensible. How to specify targets. Yeah, this is so much fun. Okay, so stuff to think about there. Anyway, this is what we're working on.